Welcome to the robotics seminar. It's my pleasure to introduce our speaker today, Adam Bright. Adam is the CEO of Skydio, which is the largest drone manufacturer in the US. He has over 20 years of experience in working with UAV systems. He's our alumni who graduated from CCL and AeroAstro, working on autonomous drone flight. After graduation, Adam co-founded the Project Wing at Google, where he co-authored numerous technical papers, patents, and was recognized on MIT's TR35 list of young innovators. Adam was also appointed by the US Secretary of Transportation to FAA's Advanced Aviation Advisory Committee. In 2014, Adam co-founded Skydio and now is leading Skydio. In the past 10 years, Skydio has shipped over 40,000 robots to over 2,000 organizations across over 20 industries, ranging from transportation to construction. It's very rare for us to have a speaker who has tremendous impact, not only in academia, but also translational success and experience. Today, Adam will tell us about his research on ethics and impact, building flying robots and scaling them in the high-stake scenarios. Is that? Adam, the floor is yours. We look forward to your talk.
Thank you. All right, well, I am really excited to be here. I appreciate the opportunity. I have a lot of fond memories from being a grad student at MIT. I can feel many of them coming back as I've gotten to wander around and meet with many of you throughout the day. I've picked a fairly heavy topic for the talk today. And before we get into it, I want to share a little bit about why. My sense is, both from my own experience in grad school and folks that we've hired and the general sort of vibe around academic talks, is that thinking a lot about military and police use of drones and robots tends to be a little bit taboo. And it's a little bit odd, I think, because a lot of the research we do is funded by the military. A lot of the applications for the technology lie in military and defense. And I think as a general topic area, it's worth more discussion, and it's something that we grapple with very directly at Skydio by virtue of the kinds of customers that we serve. So my goal is to share some of our perspective on this and some of what we do, some of what we've learned. But my real goal is to have a discussion. So I'm very interested to answer questions, hear thoughts, hear criticisms, hear concerns afterwards, and I'm happy to respond and answer and talk about anything. Because it's a robotics talk, I don't want to only focus on this. I think we've built a lot of amazing technology at Skydio. So in general, I'm thinking I'll share a little bit of the technology, what we build, how it works, sort of the trajectory of development, a little bit about the kind of the customers and the business, and then we'll get into the military and police side of things, and I'll share some examples from that. So starting with the tech, so the roots of what we've done at Skydio very much lie here at MIT. So Abe, our CTO, and I met as grad students in Nick's lab. Nick is here. Can't place him. Nick's lab in 2009. And this is the kind of thing that we were building and flying. So this was a state-of-the-art quadcopter at the time. So had a laser range scanner, 2D laser range scanner, and we were sticking Intel NUC computers on there. And actually, I saw a drone earlier today that had an Intel NUC computer on it. So I guess that's still a thing that people do. And so we were building these things. At the time, we were taking a lot of the sort of like ground robot technology that was 2D and making it 2.5D and enabling these things to fly around and map their environments. When I got here, I was interested in sort of pushing the boundaries of what you could do in more dynamic flight. So I built a fixed-wing vehicle with basically the same sensor suite that was capable of flying itself around indoors at reasonably high speeds using only onboard sensors. So because it's research, like the research caveats here, we had pre-mapped the space and done some pre-planning, but it was still a pretty advanced perception, navigation, planning, control stack that enabled all of this to work. And in particular, that parking garage, so that's the Stata Center parking garage, was about 2.5 meters floor to ceiling, and that vehicle had a 2-meter wingspan. So it was very tight tolerance when it was banked over. And the goal really was to push beyond the boundaries of what the best human pilots in the world could do, which I think we successfully did with what we ended up with. Because there's a lot of grad students in the room, I thought it's worth showing some of what happened behind the scenes and under the hood. And unfortunately, the laptop is not going to play, or the sound from my laptop I don't think is going to come through the system. So I'm going to try just holding the microphone close. Not that the audio is that important. But this is the unseen footage of getting to these successful flights. So that was actually me flying it. That was the limits of my skill as an expert pilot. Good enough. Yeah. These are early GoPros. That's probably about as much as I can take. It's painful. Did that actually work, by the way? The audio? Okay, cool. Because audio will be more important on some later videos. Let me put this thing back on. The other key to this was the hardware, and because it was like basically 2 grad students doing the whole thing. So this is the plane that we designed and built. The thing that made it somewhat resilient is that, one, it was basically rubber banded together, so every time it crashed, the rubber bands would break, and then we built this very fine foam bumper for the most expensive component on there. So that LiDAR, I think, cost, well, Nick will actually, how much did those LiDARs cost? Yeah. How many did we break? Yeah, yeah. So we tried to protect the LiDAR as best as we could. So this research, the last video there was from 2012, so that was the end of my master's project. I was introduced as an alumni. I'm also a dropout, so I was just starting the PhD program when we left to go to Google to help start their drone delivery program. The founding bet for Skydio, so this was 2013, 2014. This is when people were starting to get excited about all the different applications of drones, all the different kinds of things you could do with them. And it just seemed to us like the applications were incredibly exciting, like building these flying sensor platforms. You could do all sorts of useful stuff, but none of it was really going to work the way that people wanted it to if you need to have a skilled pilot there flying the drone, which was really the dominant paradigm at the time, and still in many industries is the majority of the use. So the big bet that we made when we started is we felt like if you could take kind of commodity sensors and compute, the kinds of things that were going into phones, you could combine it with the right algorithms, you could just unlock this like much larger scale, much easier to use flying sensor data capture platform. So that's what we started doing. We made enormous progress in our first 4 years. We launched our first generation product, the R1, which was really cool from a technology perspective, but was not a commercial success. We took everything we learned from R1, we rolled it into Skydio 2, which is what we're looking at here, which we launched in 2019. And this was a super cool product. So the target market for this was mainly consumer applications where you could basically do autonomous cinematography. And this is a sort of general visualization of the kinds of things that it's capable of. So it has 6 cameras, 3 fisheye cameras on the bottom, 3 fisheye cameras on the top that see everything in every direction. We developed a deep neural network system to figure out the 3D structure of the world around it. It uses computer vision to detect and track the mountain biker, replans hundreds of times a second using a model predictive control technique. And it's generally super, super powerful. There may be a few expert drone pilots in the world who'd be capable of doing this kind of flight, but I think it was well beyond the skills of the vast majority of the folks out there. That same technology foundation was very general, intentionally. We knew if we could build something that had these sorts of capabilities, it would be able to apply in a lot of different domains. The enterprise and government applications were always part of the long-term vision. They really started to come into focus in 2019 and 2020. Like, these markets were growing, and we had a lot of folks in those markets that started buying and using our consumer product for inspection type applications. So this is a visualization from a product we call 3D Scan, where basically you give the robot a structure or scene that you care about, and then it will automatically explore it, map it, build a real-time 3D model, use that real-time 3D model to plan a high-resolution capture path, and then basically create a sub-millimeter level, high-accuracy digital twin of the structure, which is kind of a fundamental primitive that applies in the majority of the markets we serve. So this is used for crime and accident scene reconstruction. It's used to inspect bridges. It's used for cell towers, as you see here. So it's kind of a fundamentally powerful primitive that gets applied in lots of different ways. We're now on, depending on how you count, we're now on our 4th or 5th generation drone. So at the end of last year, we launched the Skyio X10, and this really incorporates now a decade's worth of learning in building these hardware, software, autonomous systems. And we're now at a sufficiently large scale that we can do some really exciting things. So one example of this, NVIDIA is an investor in Skydio. We get very close, we have a close partnership with them. We get access to the chips at a low level, so we can do a chip down design on NVIDIA's embedded processors, which enables us to get really advanced compute into something that otherwise would probably be at least 2 or 3 times the size and weight. We design custom navigation cameras, so we customize the lenses, we pick the sensors, we tightly integrate the hardware to get exactly the characteristics that we care about: sensitivity during day, sensitivity during night, even sensitivity to infrared light, which we'll talk a little bit more about. Over the years, we've developed a really powerful spatial intelligence capability based on deep neural networks that basically go from images to depth, multiple images to depth. So these are all running on board in real time on the NVIDIA. And this is another one of the areas where I think we're getting to like superhuman performance. Like when you look at it used to be, we would develop these systems, you would look at the image and you'd try to get the network to do what you could see yourself intuitively at the image. And now these things are picking up on things that a human eye has trouble detecting in the image. So very thin structures, thin wires, features of trees and branches and other things that would be very, very difficult for people to see. We've developed a persistent visual positioning system. So every time the drone flies, it can map its environment and remember that map and use it on future flights. So it can visually reposition, which enables it to do high repeatability missions in indoor environments, in energy utility substations for repeated inspections. And this is a capability that we continue to evolve and improve. It's another one of these sort of general purpose building blocks that maps to a lot of customers in interesting and powerful ways. One of the new things that we've pushed on really aggressively with X10, so we've always had this really advanced visual navigation system. Historically, it's only worked during the daytime, which is great. There's plenty of good work that happens during the day, but there's also plenty that happens at night. And so NightSense was one of these, I think, real fundamental breakthroughs that took a combination of hardware and software. So we have active illumination on board the drone, and then we fine-tuned all the algorithms to solve all the nitty-gritty, nasty challenges that you see when you're trying to do these things in zero light environments. So backscatter is one of the tricky things here. Like the active illumination on the drone tends to light up the tiniest little dust particles. The drone itself also tends to kick up dust, which makes the problem worse. But it's one of these things that has a very strong learnable signal. The backscatter that you see in the images has a pretty clear signature to it, which with the right data and the right training, the robot can pick up on. And then it actually turns out that if you're trying to train these things to fly in zero light environments, the presence of any light in the environment, any external light is challenging. And some of the hardest things we've had to deal with are dealing with lights in the environment and transitioning between zero light and well-lit environments, which comes up in the context of like if you're inspecting the underside of a bridge, it can be very dark on the inside of the bridge. You transition out, and you suddenly have to deal with the lit environment, which has a fundamentally different kind of algorithmic profile. So this is just a sampling of a few different things, but our team is continually pushing the state of the art in a bunch of different domains in flying robotics. And all the capability that you see in our drones today is reflective of just the cumulative effort of dozens of people within the autonomy team and hundreds of people across the company that have done an amazing job of getting into the details of these problems, solving them in repeatable, scalable, powerful ways, and then just rinsing and repeating. The more robots you create, the more problems you get exposed to, and there's just this never-ending cycle of interesting stuff to work on to keep adding capability to the product. And I actually think this is not the focus of my talk, but I think we're at another one of these really interesting kind of inflection points where it's become possible to add higher and higher levels of intelligence on top of the core system using large models. And the data that we get from our customers and from the products that we already have puts us in a really powerful position to build some of these more advanced capabilities. So we have some projects that I'm pretty excited about that are sort of poking at the frontiers here that I think over the next few years will unlock sort of the next set of capabilities for our customers. So that's a little bit, I guess we can take questions throughout, yeah.
Yeah, maybe. You say the data that you already have from customers, you say you work with, like, I don't know, security, sensitive customers like military, police, do you get data back from them? Is that like awesome?
Yeah, it's a good question. So we, ultimately our customers own the data, and you're absolutely right that we work with customers who care a lot about security and are oftentimes sensitive about this stuff. So we're not getting it back by default. We're not getting it back from all of our customers, and we approach this stuff with a high degree of transparency with all of our customer engagements. But we still do get a fair amount back. Some customers are happy to share it with us because ultimately it leads to product improvements that are going to be relevant for them. And then we also have a huge internal data collection machine. We're constantly doing all kinds of flight testing in different sorts of environments and using that to drive forward development. All right, so we sell to a bunch of different industries, and we serve all these different physical industries all over the world, doing all kinds of interesting things. The really most exciting piece to me is this combination of cutting-edge flying robotic stuff mapped to, in most cases, really what we think of as the core physical industries that civilization runs on: construction, transportation, energy. And there's this kind of interesting and I think ultimately really productive tension between a Silicon Valley startup that's trying to move really quickly and taking a lot of risk and pushing the frontiers of what's technically possible, and selling to industries that oftentimes haven't changed much in the last 50 or 100 years in the way that they think and operate. But by the nature of the kind of thing that we're doing, the customers that we're serving now are the ones that are most interested in innovating, and the people within those customers who are most interested in innovating. And one of the things that I wouldn't necessarily have predicted, but has become like one of the most rewarding parts of doing this, is getting to form really close relationships with both the organizations, people at like Caltrans, which is California's Department of Transportation, NYPD, these massive organizations that solve really complex problems, getting to know them both personally and sort of organizationally. What do they do? What do they care about? And how can drones ultimately help them do it in a better, safer, more productive way? So these are just a few examples, but we're basically just underwater now in all kinds of everyday, like real world, life-saving, efficiency driving impact that these kinds of flying robots can create. And I still think it's very early days. So if I can flip through here. Yeah, these are, we talked about this a little bit in the intro. These are like high-level stats on the companies, but 2,000 customers now, up to 50,000 drones, around 200 million in annualized revenue, 700 people across a bunch of different disciplines, and by a pretty wide margin now, the largest U.S. drone manufacturer, and by most accounts, world leader in autonomous flying systems. So this was the genesis of some of the network futzing around before we got started. So, this is the live demo portion of the talk. So one of the things that I'm most excited about going forward is basically the natural conclusion of autonomy, where you don't need to have a pilot there to fly the drone. You don't need a physical person present at all. You can connect to it over the network and fly it remotely. So this is all live. So we are logged into a drone that's in my backyard in Redwood City, California, on the other side of the country. This little pilot location required is a friendly gift from the FAA. So we'll see if it actually works here. So the FAA basically requires that the person who's operating the drone has to broadcast their physical location in order to fly it. Now, when they created that rule, they're sort of anticipating that I'm in my backyard there next to it, flying it, which of course I'm not, but who cares? I'm still broadcasting my location. So the drone's now connected. I can click take off. So we're sitting here in this dock thing. Well, we just missed it. But the drone was on that arm that extended. So I'm now flying remotely, live in real time. And it's a little bit, when you're flying manually, just like playing a video game. So I can fly this thing around my backyard. Looks like the kids aren't home. My wife loves it when I do this. So the real goal is to see if we can find her. So I'm gonna reduce the obstacle avoidance margin, which will enable me to sneak through here. We'll see if anybody's home. So, oh, there she is. So she's also an MIT grad. We met on the cycling team here. She's just going to ignore us here. Yeah, no reaction. If we want to, we can pop up and inspect the solar panels. So one of the, this is a real customer application. So PG&E, a bunch of energy utilities are our customers. So we have a thermal camera here, and oftentimes faults in solar panels show up with a thermal signature. So if I switch over to thermal, we can see if anything's especially hot or cold. I'm not an expert in this myself, but those look reasonably healthy. So I'm flying manually right now, but I could also plan and schedule missions. So I could just say, like, once a day, I want this thing to go off and take this particular set of images. I can program the drone to fly out and hit certain points. And then as it's flying, as I mentioned, it's building this real-time model and map of everything that it sees. So it's now using the model and the visual positioning system to autonomously find its way back home. So it's basically going to retrace its steps and avoid all the obstacles and everything in its way, and swing back, tour of the backyard here. And then it'll, that's the dock that it took off from. So it's using vision now first to recognize the logo up on top, the Skydio logo, and then it's using the April tags for fine tuning. This is another one of these sort of real world learning. So you'll notice that the April tags are blue and yellow. The white and black ones, if you get a shadow across it, is less robust. And so the color gives us a much stronger signal that's much more resilient in the face of shadows. I prefer watching the landing from the dock camera. So you can see the drone now doing its real-time landing. Yeah. So the point of this is not for me to have one in my backyard. The point of this is for all the critical infrastructure that's out there to have just continual real-time inspection and awareness for people to never have to wonder what's happening, or if there's an emergency incident, to be able to respond to it in near real time. So that arm will now retract, and we can go back to our presentation. So what I just flew was our first generation dock system. A few weeks ago, we launched our second generation dock system. So what I just showed is daytime only, basically fair weather only. The goal, though, is to make this work in every environment that somebody cares about. So this is a video from the keynote from the product launch that we did, flying in much harsher conditions. So this is the X10, so the dock opens. This is about 2 or 3 inches of rain per hour, which is a pretty heavy downpour. And everything is still based on vision. So this is close to a zero light environment. Making the vision system work reliably and robustly in zero light, in rain, was another hefty set of challenges that our team has really done a phenomenal job on. And the whole name of the game here is reliability. Oh yeah, so the other ingredient is wind. So this is about 30 miles an hour wind that we generated on stage. So part of the reality of working on this stuff in a production context where we've got thousands of customers that are depending on it is, we can't just solve sort of like the easy fun cases and make a cool demo out of it. Like, you've really got to grind out the long tail of different kinds of conditions where somebody might want to use the product. But I think ultimately these things are super fun as well. It's just a little bit of a different flavor of many of the same challenges. So our goal with all of this, and the way that I think about what we're building from a capability standpoint, is really the world's best automated data capture platform. I think this is kind of a fundamentally new thing where you have a drone that can move unconstrained in 3 dimensions. You have the autonomy software such that it can do so without a human pilot needing to pay a lot of attention to it. You have the dock, so it can connect remotely to the internet and the network. And one of the analogies that I think about is it sort of turns drones into cloud servers. Like, these things can just be constantly in the background in an automated way doing useful work for people. And it's a whole new set of capabilities, which we're very early in exploring, I think, the full ramifications and benefits from. So that's kind of a little bit of the business. As I mentioned, we sell to 20 plus different industries. So we have customers in a bunch of different segments, but somewhat to my surprise, maybe I shouldn't have been surprised, but Skydio has become somewhat of a controversial company, and nasty news stories get written about us. So if you go and, even though we serve 20 different industries, if you go and look at what's said about us publicly, people care about 2 of them, right? So Kevin Durant was an investor in the company. This is a maximally clickbaity headline. But this is the kind of thing that tends to pop up of, what's this Silicon Valley company doing, selling surveillance technology to the government? Don't they know that, police are off there doing bad stuff? Similar flavor here. I would say peak controversy has been more recently. So, we sell to defense customers, we sell to the US, we sell to our allies, we've sent drones to Israel. So this is a poster that I went to undergrad at Olin College. This is a poster that went up at Olin. And we can talk more about this. I totally respect the students' right to see this, think this, write it, put it up. I think it's healthy to have criticism out there. But the general sort of, at least in some circles, I think the general public sentiment is that all this stuff, like working with the military, working with the police, is inherently kind of, at best, ethically compromised, at worst, outright evil. And I don't think that's true at all, and that's why I'm giving this talk. But I want to share more about some of our perspective. So I think the best way to get a handle on what does this actually mean is to actually see some examples. So this is where audio is more important. This is like the awkward futzing around part of the talk. So I'm going to play some videos. Hopefully the audio will come through of actual real-world examples.
There's a guy out here.
Is audio okay?
One of our first really significant incidents happened to be an officer Bol Shooting. Came in as a disturbance call.
Are you having beef with someone up the road? You got any weapons? Can I pat you down real quick?
So I should actually give a, so this is fairly violent graphic stuff. So whatever form of warning somebody needs, it'll last a couple seconds here, but be warned.
Make sure you don't have any weapons. Here, don't reach for nothing.
There's an exchange of gunfire.
He's running down.
He's calling for help. The cavalry arrives.
Suspect looks like he was hit.
2 drones responded.
74 said he ran in the backyard back here. George 36 is out there with the drone. There's another drone out here as well, correct?
You're tactically going to make different choices, not knowing if the suspect is still armed or not.
He's in the backyard.
He's laying down. He's on the far side.
By the use of the drone, you're able to direct the officers to the suspect.
This is his house. He's on the far side right here. He's right there.
Okay.
You're able to see that he's unarmed.
Let me see your hands!
getting in close right now.
I don't see anything in the hands.
Hands look open, they're above his head right now. He's laying down.
Keeping the officer safe and also keeping that suspect safe, getting him definitive medical care once he's in custody.
So this is a pretty heavy example, but this is the kind of thing that happens all the time in law enforcement. You know, like one of the things that I do just as a matter of practice now, anytime we visit one of our customers, I'll try to get there the day before and I'll do a ride along with the officers to just kind of see what they're doing, see what's happening out there on the street, see what they're worried about, see what they're thinking about. And these guys live in a world of just constant chaos, you know, like for whatever political opinion you have, like we live in a country where people are allowed to own guns, carry them around. So every encounter with anybody out there, the person could be armed, dangerous, deadly. And good and bad outcomes almost always flow from having information. So in this case, the officer didn't know that that guy had a gun. So when he approached them, the guy pulled the gun, shot him, the officer returned fire, the suspect was hit, he ran off into the neighborhood. In the sort of pre-drone era, that could have been a 5-6 hour thing because basically they don't know where that guy is. They don't know if he still has a gun. They're probably going door to door, backyard to backyard, guns drawn, wondering like, is this person armed? Are they gonna shoot me when they see me? With the drone, they get the drone in the air and in a few minutes they find him. They can see that he's not armed, which gives them the ability to approach him and take him to the hospital to get him care otherwise way faster than he otherwise would have. And that kind of thing is, you know, this is one example, but things like that are happening all the time. And drones are really the ultimate information gathering tool for police officers to understand risks, assess risks, make better decisions, and ultimately everybody is safer. It's safer for them, it's safer for the community, it's oftentimes even safer for the suspect. So I'm happy to answer questions about this at the end. There are certainly areas where this technology could be misused and abused, and I think it's worth a lot of scrutiny around those, and ultimately everybody here is accountable to their communities. A key part of our sales process here is having city council approve drone programs. So ultimately the police agency has to go in front of their city council and make the case to the community of why this is a good thing to do, what the impact is gonna be. And I think that's a very healthy mechanism. It's not perfect, but it goes a long ways towards having these things go in the right direction. So that was a public safety example. Now, unclip this thing, and we'll look at Ukraine. So we've shipped over 1,000 drones to Ukraine. They're being used for all kinds of things, including some stuff that I think is unexpected, but super important.
There's a guy out here that
One of our
residential area Kyiv were bombarded with 27 strikes overnight. The head of the
Тому що дуже часто як національні, так і міжнародні організації питають у нас документальне підтвердження матеріалами розслідування фактів вчинення злочину, а також обсягу завданих збитків. То звучить цифра у сотні мільярдів доларів збитків, які завдані як інфраструктурним об'єктам, так і економічним об'єктам, соціальним і тому подібне.
В кожному випадку за можливості проводиться повне фіксування за допомогою фото-відеозйомки. Крім того, на даний момент ми можемо застосовувати, як і в грозі, ми застосовували відеозйомку за допомогою дрона. Це виявилось дуже зручно та корисно, оскільки повною мірою передати фотозйомкою з землі, повної обстановки та інших деталей є неможливо. Першочергово дрон нами використовувався для здійснення 3D-моделювання.
Це полегшує роботу з огляду місця вчинення злочину, оскільки не треба лазити по цих завалах і фоткати безпосередньо фотоапаратом чи на відеокамеру знімати наслідки прильоту, тому що це є небезпечно в зв'язку з можливістю обвалів будинків, які після обстрілу перебувають в аварійному стані.
So I showed an example earlier of 3D scans. This is a product that we designed for automated inspection. Never in a million years, honestly, did we imagine that it would be used for something like this, but it's turned out to be one of the critical tools for the Ukrainians to investigate Russian war crimes. So historically, they would send their prosecutors out there, and they would basically have to wander around a destroyed building, take photos. It was super dangerous for them. It was time-consuming. There could be unexploded ordnance. The building's in obviously a terrible state. It could collapse. And so being able to put a drone in the air and very quickly take photos that give you a perfect digital copy of the whole thing is super, super powerful. And they've actually gotten a couple of indictments against Russian generals in the International Criminal Court based on evidence collected with Skydio drones. So this isn't the only thing that they're using them for, but it's certainly one of the most powerful, and from our standpoint, the least expected.
Potential area.
So I've had the opportunity to visit Ukraine a couple of times and see what they're doing with drones. I've been to Israel and met with soldiers from the IDF. I met with the drone units there who are basically constantly in and out of Gaza. And I think it's impossible to say anything about this conflict without offending somebody. So I'm not going to take a position on the conflict, but I can tell you from firsthand experience, talking to these soldiers and looking at the footage that they've shared from the drones, the primary use case for them is actually similar to law enforcement. They're going street to street, building to building. They don't know what's behind any of those doors. They don't know who's in that building. They don't know if they're armed or not. And so being able to send the drone ahead is an incredibly powerful way for them to differentiate basically civilians from combatants. And it's part of their standard operating procedure before any operation to get as much intelligence as they can from a drone, so that they can differentiate and use as little military force as possible and have it as targeted as possible towards actual combatants. So my very strong belief on this, having now worked with these customers for the last 5 or so years, is that deploying robots for police and military applications is actually one of the best areas to have positive impact, to preserve human life and to reduce suffering. And I think this is a somewhat counterintuitive result, but I'd like to walk through a little bit of why. So the first is kind of obvious, but I think it's important. This is where lives are really on the lines. These are the people who work in the highest stake scenarios where life and death are possible outcomes. So if you want to have impact, it makes sense to go to the highest stake scenarios. And robots are super powerful because they can get people out of harm's way. They can get better information to help people make better decisions. And oftentimes information is really the scarce commodity. Knowing if something's a risk, knowing where the risk is, knowing where the threat is the key variable. More often than not, they lead to less use of force. And when force is used, it can be used in more targeted and precise ways. And this last one is a little bit more forward-leaning. But I actually think it's over time possible that robots will replace more lethal uses of force with less lethal uses of force that can still accomplish the same kind of security objectives. So, we're not the first robotics or AI company to think about this stuff. I think that the default stance that people tend to arrive at is that it's, this is ethically compromised area and we should tend to steer clear. And I don't mean to pick on Boston Dynamics in particular. I think Boston Dynamics is a phenomenal company that's built incredible technology, and I respect them for taking a stance here. I think it's a lot of folks are sort of afraid to talk about it. I think that they've said and written some meaningful things here. So this is one paragraph from their kind of policy on it. I'm not going to read the whole thing, but basically they're pointing out that there's the possibility of misuse and bad things happening and public trust being undermined. This is my words, not theirs, but it's basically like summarized as it's possible that bad people might do bad things with weapons on robots, which I think is certainly true. And I actually think it's interesting to think about what does that really mean. So this is a drone product. This is from one of our competitors, DJI. DJI's stated policies, they generally don't engage explicitly with the military. But this is the same product from a non-state terror organization in the Middle East that has modified thousands, if not tens of thousands of these things. So this is the drone modified to drop a grenade. And what they've done is they basically put a photo sensor over one of the LEDs and hooked that up to an actuator. So it's not integrated in any electronics way with the vehicle's flight control system. It's basically just like you flip on the light and it'll drop its payload. So it's the kind of thing that maybe not be impossible, but extremely difficult for somebody designing this drone to prevent somebody from doing this. Like, it's not using any special privileged access to the platform. And one of the fundamental things that I think we have to grapple with is that bad people typically don't care about policies. So you can make whatever policy you want, but the worst actors out there aren't going to care what the policy says. They're going to care what's physically, technically possible. And so you end up with this pretty strong adverse selection where the folks who have higher ethical standards are more likely to adhere to the policy and care more about what it says. And the people with lower ethical standards are less likely to care what it says. And so if your plan for enforcement is policy, you tend to, around what's allowed and not allowed with your system, I think you kind of inevitably bias away from good actors and towards bad actors doing bad stuff with the system. And one of the other things, like I have kind of a unique level of access. I've gotten to work with senior military officials in the US and our allies, but I don't think it actually takes that special of access to see this. One of the things that I've come to really deeply appreciate is that governments and free democracies take these things very seriously, even within the military, and have very advanced policies in almost all cases. So folks may or may not have heard of this. There's actually a fairly well accepted sort of law of war in international humanitarian law with the set of 4 principles. I'm not going to read the whole thing, but these are fairly well thought through things that come from historical standards. So they talk about things like necessity, humanity, discrimination, basically separation of civilian and armed forces, proportionality. And these basic principles map out in very detailed ways to what kinds of products and technology you can use and how you can use them and how commanding forces make decisions and how this stuff needs to be tested and assured. There's actually a whole policy division of the US Pentagon that thinks deeply about this stuff and tries to map these in practical ways to guide ethical behavior by the US military. So as I said at the beginning, my main interest here is actually in a discussion and hearing questions, thoughts, concerns, criticisms. Before we get to that, two sort of closing thoughts. One of the other things that I've come to appreciate is that it's really important to be humble about what we're experts in and what we're not. Like I've spent most of my life thinking about designing algorithms for flying systems, and I know a lot about it. There's always more to learn, but myself and others at Skydio are probably amongst the world experts in this sort of technology. We are not world experts, at least not myself and the roboticists on the team. We have folks from military backgrounds. We are not world experts in the military use of force and the ethics of military use of force, which is not to say that we shouldn't think about it, we shouldn't care about it, we shouldn't learn about it. But there are people who are world experts in this, who spend their whole careers thinking about this stuff and oftentimes have deep personal experiences in armed conflict. And I think one of the mistakes that gets made is people sort of sit there in the confines of their office in Silicon Valley and try to prescriptively prescribe what's good and what's bad. And it's not to say you shouldn't think about it, but I think you've got to be humble in thinking about it, about what you really know and what you don't. And then the second one, which I think is super important, which I very, very much believe is positive impact is more important than purity. Like, if you want to make sure that nothing bad ever happens with one of your systems, the only way to be 100% sure of that is to not build and ship any systems. But the net good that can be created by going into high-stakes scenarios, delivering the product, working with customers there, learning from them, improving the product, trying to shape it towards things that are going to deliver bad outcomes or deliver good outcomes is enormous. And I think the world is better off if we err on a posture towards thoughtful engagement rather than trying to stay away from anything where bad outcomes or controversy is possible. So with that, I am super interested to hear thoughts and questions, really of any variety. Like if you think I've missed something, if you think I'm wrong, I especially want to hear from you.
We probably have 10 minutes for questions from the audience.
So how does Skydio think about... Just wait for the mic.
So how does Skydio think about its customers, like governments and stuff, weaponizing its drones, like apart from the kind of surveillance or information gathering use cases?
So there's kind of a strategic answer to this and then an ethical one, and the two are somewhat separate but related. From a strategy standpoint, our goal is to build the world's best automated data capture platform. And that's an incredibly hard, ambitious thing to do. And in general, the narrower your focus is, the more likely you are to succeed at achieving it. And that's really what we're all about. Like the market opportunity that unlocks is enormous. It's at maturity, very general purpose. It applies to a bunch of different industries. And it's pretty different from trying to build the world's best lethal flying system. And there are companies that are focused on that. And I expect them to be much better at it than our systems are. Having said that, it is certainly possible, and I showed an example of this from a competing product, it's certainly possible to put a lethal payload on one of our products. My view, in line with everything that we've talked about, and our position as a company, is we will be thoughtful about which customers we sell to, but we're not going to tell those customers what they can and can't do with the product. And I think the place that you have to put yourself, like where the rubber kind of meets the road on this, it's sort of abstract to say we don't like the idea of somebody putting a grenade and dropping it from one of our drones. The rubber meets the road on that when somebody's life is on the line, they're in a trench, they've got one of your drones, and they think that doing this is a necessary, important thing to do for their mission and their survival. And so if you want to tell them, it's one thing to sort of write in a document, you can't do this. I think if you want to do that, you've got to be prepared to explain to the person in that situation why they're not allowed to do it. And fundamentally, I don't think there's good answers to that question. I think that if you're going to tell them they can't do it, I think you probably shouldn't have sold them the drone to begin with. And I think not selling them the drone is a worse ethical position than selling them the drone.
Thank you.
Thank you for the talk. Kind of around that same line, I was curious, especially when you pointed out the possibility for more non-lethal options to be used as you introduce technology to these high-risk scenarios. You eventually have to cross a line where you go from sort of gathering visual information into physically interacting with people in some sort of non-lethal or marking way, like trying to mark criminals or incapacitate someone. What are the current policies that exist, both internally and in a broader sense, governmentally and whatnot, about the ethics of doing that?
So I believe from sort of a legal technical standpoint, this is like an FAA rule, you're not allowed in the US to put a weapon on a drone. Now there's some debate if that drone is indoors, maybe the FAA has no jurisdiction. But legally, I think it's either gray or black towards you're not allowed to put a weapon system on the drone. Now that may change. I think the examples, the scenarios where you can imagine this being most relevant are basically active shooter scenarios where you've got somebody like armed with a gun who's either going to or is in the process of taking life, and potentially being able to use a taser or something to incapacitate them could be life-saving intervention. One of our partner companies, a company called Axon, that invented the taser, they make body cameras, they make evidence.com. They have talked about this and are generally interested in this general notion of putting one of their tasers on a drone. The things that they've said, which I tend to agree with, is if you're going to do that, you never. So I'm a big believer in AI, and I think we're headed towards some form of, it's hard to define, but some form of superhuman intelligence. So with that out there, even with superhuman robotic systems, or maybe even the possibility of superhuman intelligence, in my view, I think you always want to have very clear human accountability, and that's kind of the most important piece of it. You want a human who's making a decision and is ultimately responsible for that decision, even if the decision is actuated through a very sophisticated technology stack. I view the technology builder's role is to make the system work as well as it can with as narrow a probability distribution of what it will do, and then to really clearly explain that probability distribution, like the mean and the variance, to customers, and have them then take responsibility for using it and accepting the consequences of using it. And so I don't think I think it's very easy to come up with examples where this would be positive intervention, life-saving technology. I don't think we should inherently steer away from it. I think we should always be looking for ways to make sure that human accountability is super clear. And I also think it's always healthy to think about the alternatives. What are the bad things that can happen if you do it? What are the bad things that are already happening by virtue of not doing it? And weigh those two things together, not just the bad that could come from doing it.
Thanks for the talk, Adam. I think the first thing I want to say is thanks for bringing this discussion to this community. You mentioned that often we shy away from it, and I think that as engineers, we have a tendency to go, oh, what is the coolest technology? I'm just going to go work on that, and I don't have to think about some of the implications. So that was great. So you mentioned a lot of use cases where we can see positive effort and positive impact, and I certainly don't think what I'm about to say next reflects a general case, but I kind of wanted to pick up on probably the most controversial part of your talk, which is Skydio in Israel and sending drones to Israel. So you mentioned that part of what Skydio wants to do is to preserve human life and prevent suffering. And kind of the question that I want to ask here is for whom? So I think that it doesn't really matter what anyone's opinion is in this room based on that. But the facts are that if you look at the death tolls on both sides in Israel and Palestine, there have been 10 times as many casualties on the Palestine side, with over 50% of those being civilians. And the ICJ, the International Court of Justice, has declared Israel as an apartheid state. So we kind of have some kind of external objective opinion based on this. So there was another interesting thing that you said, which was, I think we need to be thoughtful about who we sell to based on how they're going to use these things. And so I guess one of the key points that I'm coming down to here is it would be a net positive to not sell to Israel. And perhaps one of the answers to this would be, well, a lot of the civilian casualties have come from, weapons of mass destruction that have killed lots of people. But we've actually seen documentation on YouTube and other publicly available cases where some of the military members of the Israel Defense Force have shown them scoping out and finding children and individual members, shooting children. So they boast this increased capacity to distinguish between civilians and military, but we've seen them use it in a way that actually targets civilians. So I guess that's a long way to say, if we're interested in selling to people who only use it in the right way. What are your thoughts on selling to Israel?
So it's going to be hard to answer that question without expressing too much of a political opinion. I mean, I think there's a political perspective embedded in your question, which is fair. Well, I'll say a few things. I think some related to us and some not. I think it's very difficult to look at what's happened in Gaza and not see just terrible tragedy and terrible human suffering. I think that's hopefully one of the things that's like objectively clear and objectively true to anybody looking at the situation. I think and I think that I think the causal chain that leads to that and the moral culpability of different ideas, different governments is obviously a matter of debate with various opinions out there, and I don't think it's like. I think an honest assessment is that it's not like 100 or 0 any which way, and I'm not in a position, and I wouldn't defend everything that Israel or IDF has done. Like the nature of war is that it's tragic and terrible, and mistakes can be made with good intention, and even amongst ethical militaries, sometimes individuals will do terrible things, and I think that's unfortunately part of the reality of these things. I can tell you how we approach this as a company. In general, we draft pretty hard behind U.S. foreign policy, which is not to say that U.S. foreign policy is perfect. It's definitely not. There's plenty of examples of the U.S. making terrible mistakes, but the U.S. government is ultimately democratically elected. It's accountable to the citizens. We all have a stake in it. I've met a lot of the people involved in these things that make these decisions, and I don't think they're perfect, but I, on balance, think that they are trying to do the right thing. This is an area where U.S. foreign policy has been somewhat mixed. Our political leaders have said different things, but Israel is still a critical ally of the U.S. that still enjoys quite a bit of U.S. support. We're not always going to 100% align to U.S. foreign policy, but in general, we will err very strongly in alignment in the kinds of customers that we serve. I can speak from firsthand experience, having been there and having spoken with people there, that I very strongly believe that this class of drone is leading to less human suffering. I don't think that the IDF is systematically out there trying to kill as many civilians as they can. You can quibble with judgments that they've made, but I don't think that that's like the mission or the intent. And in general, I think the more precision that they have, the less likely there is to be civilian suffering. That may not be 100% true, but I think that as a general rule, that is the case. And I understand, not everybody's going to agree with that, but that's my opinion based on some personal experience and a fair amount of reading and research about it. So I think it's it's obviously the most polarizing, difficult conflict that's going on today, and we have there's probably a diversity of opinions in this room. There's a diversity of opinion at Skydio. It's something where we've had like internal debate. I get asked similar questions internally, and I think all that is healthy as well. It forces everybody to think about this. I don't think there's a perfect answer, but ultimately we wouldn't be there if I didn't feel like we were having positive impact.
Like, really quick question. Thank you so much for the talk. It's a difficult topic. Thank you. But my question is, so your MPC is about like 100 hertz. I'm like, right? I mean, like, that's so impressive. I mean, like, we should talk about it. But I've been using MPC for multi-agent trajectory planner, and then I want to know, because we're using like hard constraints, and then like usually it's like about 10 hertz, max like 20 hertz, which is okay. But I mean, 100 hertz, like, do you have it? Like, I read
paper somewhere about Skydio, about you guys using unconstrained MPC, I assume. So like that, I believe that reduces computation time. But like, do you have any, maybe like horizon is like very short? I don't know. Like, do you have any tricks and like tips and stuff? That'd be great.
So the exact frequency that we're running at is classified. It's,
I see.
But it's running pretty quickly, and we've done a bunch of work recently to make it run faster. You know, this is one of the areas where I think working on this stuff in the context of a company with like significant resources is different. Like, you know, we've got brilliant teams of people, many of them like former master's PhD students that are using the full weight of their insight and work to figure out ways to like make these things more efficient, run faster, figure out how to like put the computation where it matters most. So, you know, we're doing a ton of things from like low-level software optimization. So we have a library called SimForce that we open sourced, which is super powerful. If folks aren't familiar with it, I think it's worth looking at, but basically enables you to write symbolic expressions in Python and formulate optimization problems, and then auto-generate basically the most efficient code that you possibly can. It auto-generates like massive C functions with a bunch of you know, common term optimization and other things that you'd never do if you were writing natively in C++ manually to get really performant optimization. So that's a key piece of it. You know, the window that we're looking at is a key piece of it. Like everything that you can imagine, we've pushed on. What you initialize every iteration with matters a lot. So there's all kinds of things like that to make it run faster and faster.
Gotcha. But you're not using any learning module yet. You're just like purely optimization based. So for planning, not the visual part, but yeah.
I wouldn't say that either.
Oh, okay. All right. Yeah. All right.
But it's, you know, the primary backbone now is an optimization-based MPC.
Okay.
Yeah.
Thank you.
Hey, thanks so much for your talk, Adam. My name's Arthur. I'm a Navy vet, so definitely understand where you're coming from on the kind of the law enforcement military side. One of the things that I think that the U.S. does is it overclassifies things, and less people serve today than ever have in the past in terms of percentage of the population. So I appreciate you bringing up this discussion. My question is more about kind of the business side. Where do you see the business going in the next 5 years? And then also from like a geopolitical sense with your competitors, like how do you guys source a lot of your parts and stuff from the US, or how are you guys dealing with the supply chain issue to try to compete with your competitors?
Yeah, both great questions. So I think, you know, building companies and doing startups is hard. It's also a lot of fun. And I think the market in the industry has never been at a more exciting, fun point. So the centerpiece of our vision has been about like autonomy and leverage, like giving people like more capability to do more useful things, to have more positive impact. And the doc that I showed has been really our primary focus for a long time, like 5 or 6 years, like building all the pieces to make that really work. And it's really working now. And we have customers that are deploying it at, I would say, like low to medium scale. But I think over the next 5 years, we're going to see drones for a lot of these critical industries. Drones themselves are going to be like infrastructure. So I think every energy utility substation in the US will eventually have a dock drone at it that can perform real-time inspections and basically gives you like complete digital access to the energy grid. So if the power goes out, you can get a drone there in a matter of seconds. You can figure out what's going wrong. You can direct resources to the right place. You can fix it. The power comes back on faster. It's safer. It's great. One of the applications that I'm most excited about is having drones automatically respond to 911 calls. So we have customers today, like New York NYPD is doing this. They're flying Skydio drones off of rooftops, out of docks in response to calls, where it might take the responding officers on the ground 5 minutes to get there. The drone can get there in 60 seconds. You can see if there's a crime in progress. You can see the evidence. You can help the responding officers make better decisions. They know if somebody's armed or not. I think over the next 5 years, that's going to become a fairly standard thing. People will just expect if you call 911, you can have a drone show up in a matter of seconds, which I think will be incredibly powerful. So, it's been a 10-year journey to get to where we are. I think the next 10 years are really, we're going to see like the scaled deployment of these systems in ways that will fundamentally transform some of these core industries. The second piece of your question, the geopolitical competition, is super interesting. So we started the company in 2014 before competition with China was was really on anybody. I mean, you know, people were thinking about it, but it was just an entirely different universe from where we are today. We, from the beginning, manufactured all of our drones in the US, and we did that basically because we felt like it just made the most business sense. Like, these things are really tightly coupled aerospace systems, and engineering and manufacturing end up being pretty closely linked because of that. That has turned out to be incredibly important from a security standpoint and also from a competitive standpoint. So one of the major themes in the industry over the last, I would say, 5 years, as drones have sort of migrated from consumer toys to critical tools for critical industries, is that it's kind of untenable to be wholly dependent on an adversary for these products. You know, people can draw the line in different places, but somewhere between like, you know, the consumer toy and the thing that the US soldier is using, like, people generally agree it's like probably not a good idea to be dependent on an adversary for this technology. And I think that's both an opportunity and a responsibility for us. You know, it's an opportunity in that there's headwinds for our Chinese competitors that are tailwinds for us. I think it's a responsibility in that I really believe for you know, geopolitical and national security, it's important to have a strong US drone industry. And we're by a pretty wide margin the largest US drone manufacturer, and I think that's kind of that's a important torch to carry. And I think it's important really no matter what outcome. You know, hopefully things don't escalate with China, but even if they don't, I think it's important to have alternatives from a security standpoint.
Okay, one last question due to a time constraint.
So I want to take it back to the, I guess, ethical discussion we were having earlier. I think the question of selling, the question of selling to Israel and the IDF is just the question today. I think the reality is that as, this technology, robots become more adept at intervening in life-saving situations, they also, the possibility that they can be more lethal or be misused also increases. And I think the most pertinent point here is regarding something you said earlier, is it's not just bad people doing bad things. And, you can't stop it by simply not selling to those people. So as someone who also works on these dual-use technologies, the question that I ask myself a lot and that I want to ask you, if, when I grapple with, should I even be working on these things at all, is, in your mind, is there a line beyond which either, you don't, beyond which you maybe change your policy, choose to not invest in a certain technology, choose to develop in a different direction, or I guess, is it a question of would you always still want to be working on this for its benefits? And I recognize that this is a very hard philosophical question also.
Yeah. So my general view on this is the positive impact versus purity framing. And I think the possibility of something bad happening, the reality of bad things happening, always needs to be weighed against the totality of what's happening and the totality of the impact of what we're doing. And I think that our human brains and human psychology tend to focus more on the negative, which is fine. It makes us more risk averse. But I think you always need to weigh it against the totality. I can certainly imagine scenarios where unstable political situations in the US, states of geopolitics, where my concern, our concern as a company would be might cross some threshold where it would change some of how we think about this stuff. I think it's always important to be responsive to the reality, what's happening and what are people actually doing. I think that we face a slightly easier version of this question. There are companies out there that are basically focused on building the flying bomb, in some level, the drone that is designed to go and attack individual people in a highly automated way. We're not doing that. I don't think there's anything inherently wrong with doing that, but I think it certainly raises the stakes of the kinds of questions that you're thinking about on a day-to-day basis. So I think it's always, I think it's always important to be responsive to the reality of like what's happening. But in general, like we will err towards like, let's make our products as awesome as they can be. Let's think about the ways that they could create negative outcomes. Let's try to design such that that's less likely to happen. Let's work closely with our customers to train and enable them in ways that are gonna lead to more positive outcomes. And let's like turn the crank on that cycle. You know, one example of this outside of the military context, we're building in public safety world for police, we're building a transparency dashboard, which makes it very easy for our police customers to publish the flights that they're doing. So like on a 24-hour delay basis, they can publish their complete flight records for their citizens to go and look at, which I think is a really powerful mechanism for community engagement and accountability. You know, you can see where your local police agency is flying the drones, you can get some sense of what they're doing from that, and the more people see it, I think the more that they will see the positive impact. But if something bad happens, it also creates a data record to look at it and hold people accountable. I think we're...
Yeah, I think we're over time. So
okay.
Probably just for the interest of time, let's stop here. Let's thank our speaker again.